So we're going to talk about values of circular functions, i.e. we're going to talk about really using the unit circle. So I talked about in another video how the unit circle is constructed and the domains of trig functions and using circular functions and everything with this. So I have a video on that. So just a reminder, so the y-coordinate on the unit circle represents the value of sine of s or sine of theta, depending on how you're thinking of that function. And I broke down the s versus the theta in my other video. The x-coordinate on the unit circle represents the value of cosine of s or cosine of theta, again, just depending on how you're thinking about it. Now, when thinking about values of circular functions, we generally treat our angle measures as being in radians. So unless you are directly told that you're using degrees, you're probably using radians. And so for your calculator, you must make sure that it is in radian mode. So a lot of times your calculator will be in degrees, and so now you need to switch it to radians, particularly for what we're going to talk about in this video. So what I want to do is I first want to just go through like using the unit circle and making sure that we feel good about that. So, okay, I have sine of pi over 2. So I'm going to go to my friend, the unit circle, and so I look for pi over 2 in terms of my radians, so it's right here. And then I'm interested in sine, so I look at the y-coordinate, which would be 1. So sine of pi over 2 is just going to be equal to 1. So what about cosine of pi over 2? So same thing, right? So we're still here at pi over 2, but now I just need the x-coordinate. So cosine of pi over 2 will be equal to 0. And then finally, for tangent of pi over 2, so to calculate these other trig values or trig functions, so then you just have to think of what do you know about these functions in terms of sine and cosine. So I know that tangent of pi over 2 will be the same thing as sine of pi over 2 over cosine of pi over 2, which are the values that we just found, right? So this would become 1 over 0. And so in this case, I can see that this would actually be undefined because, you know, I can't have a 0 in the denominator. So that would be the answer there. Okay, so now what I want to do is let's just do that one more time. So let's use 5 pi over 4. Maybe you want to pause the video here, try this on your own, and then hit play when you're ready. All right, so I'm going to go to 5 pi over 4. So let's see, 5 pi over 4. So I start here, and boop, there we go, 5 pi over 4. Okay, so I need sine of 5 pi over 4, so that's going to be negative square root of 2 over 2. So I just take the y-coordinate. So this is negative square root of 2 over 2. Then for cosine of 5 pi over 4, so I just take the x-coordinate, so that would be negative square root of 2 over 2. And now, for tangent, so now I can just take the value of the sine function over the value of the cosine function. So this comes out to negative square root of 2 over 2 over negative square root of 2 over 2. So that's the same thing, one thing over the other. Those cancel out to just make 1. So that would be the value in that case. And so that's the work that you can go through to figure out some of your other trig values. Now, I want to take a moment just to get you to appreciate how great this is, just in case you forgot. So I want to compare methods. Because prior to using the unit circle, we were using reference angles. So we're going to compare methods. Let's use reference angles to find the value of sine of 2 pi over 3, and then let's confirm our answer using the unit circle. Okay, so sine of 2 pi over 3. So first things first, we have to convert this to degrees. So I take 2 pi over 3, and then I multiply that by 180 over pi radians. And so if I multiply those things together, I will get 120 degrees. Okay, so next I have to think about where does 120 degrees fall. It falls in the second quadrant. And so when I'm in the second quadrant, we've talked about this in other videos, second quadrant, if I'm trying to figure out my reference angle, I'll take 180 degrees minus 120 degrees. And so that gives me the equivalent of a 60-degree angle. And then I have to think about what is the value, is the sine of sine, is it positive or negative in the second quadrant? So sine is positive in the second quadrant. So what that means then is that sine 2 pi over 3 is equivalent to sine of 60 degrees. And we talked about how to get to sine of 60 degrees in other videos. So this value here then, if I just go through my chart, this would be my value right here. So square root of 3 over 2. Okay, and so that would be the answer here. So that's a lot of work to figure that out, right? So now what I want to do is I just want to compare using the unit circle to figure this out. So if I use the unit circle, so for sine of 2 pi over 3, so I look at my unit circle, there's 2 pi over 3, so I just need the y value, square root of 3 over 2. So is that the same thing? Yep, square root of 3 over 2. So that checks out, so it's okay. So going forward, we really just want to use the unit circle to figure these things out because it's just so much more efficient. Now, what about other angle measures? Well, if you have other angle measures besides what's on the unit circle, then you need to use a calculator. Although you do, once again, I'm just repeating this, you want to ensure that it's in radians. So let's just take a few minutes to do a few of these and just give you a second to make sure your calculator's in radians. So as far as calculating the rest of these go, I mean, you really cannot do this without a calculator. So for instance, cosine of 1.72, so I've really just got to plug that into my calculator. And I get negative 0.14, maybe 149, I'll just round. We'll round to the nearest thousandth in this case, just to make sure that you're doing it right. So what about sine of negative 3.54? So again, I'm just gonna plug this into my calculator. And so my calculator will spit out that this comes out to 0.388. Again, I'll just round to the nearest thousandth just to help you make sure that you've got the right number. Now, what about cotangent? Well, we know that cotangent is equal to 1 over the tangent of 1.438, so you might have to make a little bit of a manipulation. But then I can just plug that into my calculator, right? So 1.438, and in this case, I would get that this equals 0.134, again, if I round it. And so, you know, if you just have other angle measures, then it's a little bit more straightforward in some ways. So that is it for how to work with circular trig functions and the unit circle, and then when not to use the unit circle. So thanks for watching, guys. I'll catch you in another video.